10th CBSE Chemistry, Chapter Carbon and its Compounds. In this video, you will learn about the allotropes of carbon and also their structure. Allotropes are nothing but the different structural forms of an element. Carbon has three different allotropes: diamond, graphite, and Buckminsterfullerene. All the three different forms of carbon are the pure forms of carbon, that is, diamond, graphite, and Buckminsterfullerene contain only carbon atoms, hence are called the pure forms of carbon. But still, we see that they all are different. Diamond, graphite, and Buckminsterfullerene are different from each other structurally. Though they all are made up of only carbon atom, what makes the difference? The difference is in the arrangement of atoms in these elements. Now let us see how the atoms are arranged, leading to the different allotropes of carbon. Diamonds. Observe the arrangement of carbon atoms and the number of bonds formed by each carbon atom. The carbon atom in diamond are bonded with one another by 4 bonds. The bonds are covalent and each carbon forms 4 covalent bonds. Hence, we see that each carbon is bonded to 4 other carbon atoms, and this gives rise to a compact and rigid three-dimensional arrangement of carbon atoms, which in turn results in the formation of tetrahedral units. The network of strong covalent bonds in diamond is responsible for its rigidity. The rigid structure of diamond in turn is the reason for its hardness. Graphite is also made up of carbon atoms and covalent bonds. But each carbon atom is linked to 3 other carbon atoms in graphite, unlike in diamonds. Hexagonal rings are formed, which are arranged in layers. These layers are held together by weak van der Waals forces. You can observe from the picture that there are 3 layers of carbon atoms which are held together by weak van der Waals forces. These layers also form sheets which can slide over one another, and this property makes graphite soft. The third allotrope of carbon is Buckminsterfullerene. Buckminsterfullerene is a spherical shaped molecule formed by 60 carbon atoms, hence the formula C60. There are 20 hexagonal and 12 pentagonal rings in one molecule of Buckminsterfullerene. The allotrope is named after American architect Buckminster Fuller, who designed a similar dome-shaped hall for international exhibition. You can see that the Buckminsterfullerene molecule resembles the shape of a football with pentagons and hexagons in it. The 3 allotropes of carbon have different properties, though they all are made up of a single element, that is carbon. They are all pure forms of carbon. This difference in the property is because of the arrangement of atoms in them. You can see that diamond, graphite, and Buckminsterfullerene all have different arrangements of carbon atom. Among the 3, diamond and graphite is known to man from centuries. But Buckminsterfullerene is a recent discovery and its properties are still investigated. In this video, you learned about allotropes of carbon and their structure.